Alright, section 12.2 is on a pretty important concept in trigonometry, and it's the idea of converting between degrees and radians. So that's one of our goals. We want to talk about what does it mean to put an angle in standard position, what does it mean to talk about something called coterminal angles, and then we'll talk about converting back and forth between degrees and radians, or radians to degrees, and then finally how to find the arc length of a circle. Alright, so first of all, to put an angle in standard position means that the angle starts at 0 degrees. It starts on the positive x-axis, which is right here where I put that green line. Remember, an angle looks like this. It has kind of an initial side right there. That's where the angle starts opening, and then it has a terminal side. That's where the angle ceases to open. And then this point in the middle is called a vertex. So if you look at that axis, the green is where the angle opens, and then the yellow right here is where the angle finally closes, and this is like the entire opening of the angle. Okay, so that's kind of what it looks like. The terminal, putting something in standard position, means its initial side starts at the x-axis. Okay, the other thing is that angles are positive when you're going counterclockwise, and somebody I know likes to say that clockwise is, or counterclockwise is kind of like you draw the letter C. So when you're drawing the letter C, you start here and you go that way. That's counterclockwise. So this one is going counterclockwise, it's positive. If you start here and you go this way, your angles will be negative. Okay, so for example, this angle right here, you can see negative 145. That's the same as if you had gone this way. That's like a positive 145, but the other one is negative because we are moving in a clockwise direction. Alright, so it says draw an angle with the given measure in standard position. So if we start at 0 degrees right here, this is the initial side, this is 90, this is 180, and so that's why it tells us right here 215 is going to be past 180. It's actually 35 degrees past 180. So if we draw this angle, we would start here and we would go, there's 90, there's 180, 215 is a little bit further than that. So this red angle right here, that's a 215 degree angle. Okay, I'll draw the negative 41 on the same axis. Negative 40, remember, means that we're going to go clockwise this time. So we'll start here. Negative 90 is down here. I don't want to go all that way. I just want to go a little bit less than that. So this right here is about negative 40, and in a sec we'll talk about what that is as a positive. You might be able to tell. Negative 40 if you went the other direction, so if you went this way all the way around and you stopped right here, that's 360 except for that last 40. So that negative 40 is the same angle as positive 320 degrees. Alright, let's do a couple more here. So let's put this graph right here. Let's do both of these. Let's do 80 degrees. So here's our terminal side. Remember, 90 is here, so 80 would be a little bit less than that. There's an 80 degree angle. And then this one right here is going to move clockwise instead. So negative 105. Here's negative 90, so we're going to go a little bit past there. So we'll start right here. And then there's negative 90, negative 105, a little bit past that right there. So approximately like that. Okay, the other thing to keep in mind is that you know, angles, there's no limit to them, so you can go around as many times as you want. So for example, if you had a 480 degree angle, that's the same as doing a complete 360, which you can see right here, complete 360, and then 480 means you go a little bit extra. Question is, how do you find a little bit extra? And the answer is you just take that and you subtract 360 from it until you wind up with an angle that's in the same, between 0 and 360, which you can see right there. 120 fits that category, fits that criteria. Alright, so here's an example. Wakeboarding, they say, is a combination of surfing, skateboarding, snowboarding, and water skiing. And there's you've probably seen skateboarders do this. They do this in sports like basketball too. Somebody tries to do a dunk where they'll spin around a certain more than a full rotation. So this one says that a 540 degree rotation is one of the techniques. Draw an angle in standard position. So standard position means it starts here. It goes 540, so that's obviously more than 360. And to figure out what it's going to look like, we can just take this and subtract 360 from it. When you do that, you get 180. So this is going to look like a 180 degree angle. So let's go all the way around, that's 360, and let's go another 180, so right there. So that angle is basically going to be like that right there with those extra turns in there just to indicate that we did more than 360. Let's do one for 600 degrees now. So 600 degrees, we don't know what that is off the top of our head, so let's subtract 360 and we get 240 degrees. So standard position means we start here, we're going to go all the way around 360, and then we'll go another 240. So remember, that's 180, so 240 would be a little bit more than that, and that's about 300. That's about 600 degrees. Let's see, they have a little bit better picture than I do, but you can see it right there. Okay, so we noticed that it's possible to go multiple rotations, and the key idea that comes from that is something called a coterminal angle. So let me just have a blank coordinate axis right here. Okay, and I'll just make up an angle. Let's suppose we're going to go 60 degrees. So this is a 60 degrees angle. What angles are coterminal with 60? Well, if I start at 60 and I go a full 360 extra, okay, if I add 360 to that, that's the same as a 420 degree angle. So we say 420 is coterminal with 60 because we ended up in the same spot. Our terminal side is the same. Okay, you don't have to stop there, so let's go another 360. So now if I add another 360 to that, that's the same as a 780 degree angle, and that's also coterminal with 60. Okay, suppose I had gone the other way, so suppose I start here and I go backwards 360. That's the same as 60 subtracted from 360, and that's equal to negative 300 degrees. So this, and this are all coterminal angles. Actually, there's an infinite number of coterminal angles. How do you find coterminal angles? You basically find them by adding or subtracting 360 repeatedly, and that's how you can find angles are coterminal. So this one says find an angle with a positive and a negative measure that are coterminal. So let's just add 360 to find the positive one, and let's subtract 360 to find a negative one. And remember, these are not the only ones that we could have got, but these are two answers. We could obviously keep going. We could add 360 again, and here's another one that's coterminal. Or we could subtract 360 again, and here's another one that's coterminal. Any of those will work. Okay, this one right here too, let's add 360. So 160 degrees is a positive coterminal angle with this one. And if we subtract 360, we'll get negative 560. That's a negative coterminal angle with negative 200. Okay, now this is a key concept. We want to talk about something called a radian. What's a radian and how does it apply to trigonometry? Okay, so you can see a circle right there, and I'm just going to draw it a little bit up here, a little bit different so we can see it a little bit better. So here's a circle, and if I asked you what's the distance around a circle in degrees, you could say it's 360 degrees. Okay, let's say that the circle has a radius of equal to 1. Okay, we also know that there's another way of describing distance around a circle. We can not only describe it in degrees, but we could describe it in terms of circumference, and the circumference is the same as 2 pi times the radius. So what does that actually mean? What it means is this. If you took this radius of 1 and you kind of bent it into a sort of circular shape, so that's what I'm intending to show right there, that 1 radius, that green radius, is like you took it and you bent it, and then let's say you tried to fit it around the circle. So I'll color this red so we can see. So I'm trying to fit these radiuses of 1 around the circle. So there's 1, there's 2, there's 3, there's 4, there's 5, there's 6, and there's a little bit left over there. So how many radiuses fit around the circle? And the answer is that many right there. Remember, pi is this number. Pi is 3.14159. It keeps going. That's the same as 6.28. So what this means is no matter what size the circle is, you can always fit 6.28 radiuses around that circle. And that's exactly what a radian is. A radian is a radius. And the question is, how many radiuses can you fit around a circle? You can fit 2 pi of them. So 360 degrees is equal to 2 pi radiuses. And the actual name that we use for radiuses is radians. Okay, just to simplify this a little, since both of these are divisible by 2, you could say this: 180 degrees is equal to pi radiuses. 180 is half the circle, and half of 2 pi r is 1 pi. So let's use that conversion as we try to change things in. You might have seen this in science classes before where you use something called dimensional or unit analysis. That's kind of what this is. So remember, here's our conversion. Pi radians is equal to 180 degrees. Let's do A first. So we want to change this into radians because it's in degrees right now. Right now degrees is on the top, because if that were a fraction, that's how you write it. So in order to cancel it, I'll put degrees on the bottom, and I will put radians on top. Okay, the degrees will cancel. 30 goes into itself once, and it goes into that 6 times. And the negative times pi becomes negative pi over 6 radians. So that's what 30 degrees means. On a circle, 30 degrees would be maybe about that right there. And that's the same. You could fit 1/6 of a, or pi over 6 of a radius is around there, or about half a radian. This, remember, pi is 3.14, so you could fit about half of one of this radiuses in that 30-degree zone right there. Okay, this one is in radians right now. We can tell because of the pi. So because I want to cancel it out, I'm going to put the radians on the bottom, because radians are on top right there, and degrees on the top. The pi's will cancel. 2 goes into itself once, and it goes into that 90 times. And 5 times 90 is 450 degrees. So that's more than a full rotation. Remember, 4 pi over 2, that's the same as 2 pi. And remember, 2 pi is all the way around a circle. So this is going more than a full rotation around the circle. And that makes sense, because 450 is more than a full rotation. Okay. This is a chart. You certainly don't have to memorize this, but there are 3 or 4 that are used so often that it's useful to have them memorized. We just saw in the previous example that 30 degrees is pi over 6. These other 3 that you see here, the equivalent ones, those are useful to memorize. So 90 degrees, I'll show you that conversion. 90, remember, degrees are on the top, so I want to put them on the bottom. And there's pi radians for every 180 degrees. 90 goes into itself once, and it goes into that twice. So pi over 2 radians is the same as 90 degrees. So that's useful to have committed to memory, just because we use them so often. Okay. Last concept I want to talk about is something called arc length. And we already kind of talked about this. Arc length is based on circumference. The circumference of a circle is equal to 2 pi times the radius. And they give you this formula right here. The formula for arc length, they use S to stand for arc length. It equals the radius times the angle in radians. And that kind of makes sense, because the arc length around an entire circle, just prove to you that this formula works, the arc length around the entire circle is this right here. That's the angle, that's theta, and that's the radius. So theta times radius is this right here. The name for the arc length around a whole circle is the circumference, but you don't have to go around the whole circle. You can just go a little bit of the way. So I'll show you kind of 2 ways to do this, and you could just plug it into the formula, but I think it's a little bit nice to understand sometimes what you're doing. So let's do that. Monster truck tires have a radius of 33 inches. So here's our monster truck tire. How far does a monster truck travel in feet after just 3/4 of a tire rotation? Okay, so if we were going to go all the way around the circle, we would do 2 pi times the radius, 2 pi times 33, which is 66 pi. But this is telling us we're going 3/4, so let's just take the whole circumference and we'll multiply it by 3/4. And 2 goes into that twice, and it goes into that 33 times. So we'll have 33 pi times 3, which is 99 pi. And remember, this was inches, so 99 pi inches. Okay, that's how far it goes. We're basically just taking the fraction of the circle we travel, which is 3/4, and that's that distance right there, which equals 99 pi inches, and they want it in feet. So you would just divide that by 12 to get your answer in feet, whatever that turns out to be. Okay, the other thing that's important to remember is angle measure and arc length is always done in radians. Degrees are just a man-made concept. Somebody just kind of made up the idea that there's 360 degrees, but arc length and radians, those are actual lengths in real terms. Radius is not a man-made concept. It's something that was discovered, the relationship between diameter and circumference of a circle. So we always put arc length in radians, not degrees. Okay, let's do this last one. So it says a circle has diameter of 9 centimeters. So remember, this is our arc length formula. I'll show you kind of both ways. So here's the circle. Not a great circle there, but I'm doing it by hand. So a diameter of 9 means a radius of half of 9. The radius is half the diameter, so a radius of 4.5 centimeters. Okay, and it says find the arc length of the central angle. Central angle is the angle that has a vertex at the center. If the central angle is 60 degrees. Okay, so here's our formula, and I'll show it to you both ways. I'll show it to you kind of the more intuitive way and then the way with using the formula. By the way, the formula only works if that is in radians, so we'd have to change 60 degrees into radians, which we could do like this, and those cancel, and that turns out to be pi over 3 radians. Okay, so using the formula, we could say the radius is 4.5 centimeters, and the theta, the angle in radians, is pi over 3. So you multiply those together, and let's see, that becomes 1. 3 goes into that 1.5 times. That's the same as 3 pi over 2, and they tell us to round to the nearest tenth. So I think that's roughly 4.71 inches when you round it, because pi is 3.14, so 3 times, is that right? 3 times 3.14, yeah, I think that's 4.71. Okay, how can you do it the other way? Well, we can do it by noting that the circumference is 2 pi r. So in this case, 2 pi times 4.5. That would be 9 pi. That's all the way around the circle. We didn't go all the way around, we went 60 degrees around. What fraction of the circle is 60? Well, what fraction would 180 be? 180 is a half. How do we know it's a half? We just do 180 over 360. So in this case, we're going 60 out of 360, which is 1/6 of the circle. So we'll just take our circumference and take 1/6 of it. And when you do that, you end up with 3 pi over 2, or 1.5 pi, and that's the exact same as that answer right there. So that's kind of two different ways to do it, either using the formula or kind of reasoning it out based on the idea of circumference, and that is section 12.2.